Okay, let's talk about what was I going to say? Stretch compressions. Okay. Now, let's look right here. Let's say, for example, I want to stretch this vertically by a factor of, okay, so let's say I want to stretch it sine of x by a factor of 2. I basically want to, I don't need to phrase it any simpler. That's really what it is. I mean, that's easy to understand. Okay, by a factor of 2. Watch this. Okay. Sorry, vertically stretch it by a factor of 2. There you go. That got stretched by a factor of 2 vertically. Okay, don't ignore what I typed right now. I just want you to visually acquaint yourself with how a vertical stretch of a factor of 2 looks like. Okay, one way of thinking about it is that the height of the highest the red goes is positive 1 for your y value. The lowest it goes is negative 1 for the y value. Okay, but now if you look at this blue, the highest the blue goes as a y value is positive 2. The lowest the blue goes as a y value is negative 2. Okay, so the amplitude, so to speak, the peak and the valleys, the highs and the lows, used to be 1, negative 1 for your y values for the red. After we stretch it, your peak and the valleys, the high and the lows for the blue now goes from 2 to negative 2. Okay, you can think of it as the range instead of peaks and valleys, highs and lows. Okay, all right, because domain is x's, ranges is y's. Okay, now if I want to compress it by a factor of 2, okay, if I want to compress it by a factor instead, sorry, I misspoke. If you want to compress it by a factor of 1/2, then watch this. Boom. Now, if you look at the green, the range is going to be 0.5 positive and 0.5 negative. Okay, 0.5 positive and 0.5 negative. Okay, again, don't pay attention to the left side. Just look at the right side. I just want you to visually acquaint yourself, visually familiarize yourself with how it looks like when we compress and stretch. What happens to the y values? Okay. All right, now let's look at the numbers. Now check this out. Let's just focus on the second one because I don't want to throw too many things at you visually. If you look at the second one, okay, you can visually tell we vertically stretch the red by a factor of 2 to get to the blue. Okay, let me say that one more time. You vertically stretch the red by a factor of 2 to get to the blue. However, I said vertically stretch by a factor of 2, yet it says 1/2. Okay, yet it says 1/2. So again, this is where you have to think in opposite hats. Okay, you have to think with your opposite hats. Okay, we're gonna start creating like here. Let me see how I'm gonna phrase this. Okay, so this is how I'm gonna phrase this. Okay, we're gonna use 1. So if I were to give you a problem like this, okay, if I were to give you a problem like this, how would you do it? Okay, how would you create the bullet points? Okay, you would think like this. This is how you would think. You would use 1, the whole number 1 as your reference point. Is 1/2 less than or greater than 1? Okay, the answer is that it is less than 1. Okay, we're using 1, the whole number 1 as our reference point. It is less than 1. Okay, so because it's less than 1, you would think that it is a vertical compression because it is less than 1. Keyword less. You would think it's a compression. However, because we have our opposite hats, it's going to be a stretch. Okay, so this is going to be a vertical stretch. Okay. Okay, by a factor of now. Okay, by a factor of how many now? Okay, this is where we're going to create a mini multiple choice problem for ourselves. Okay, we're going to create a mini multiple choice problem. You're going to write the 1/2, which is what's given to you, or the reciprocal. Okay, or the reciprocal. Okay, now, because we said stretch, well, stretch is obviously you're going to pick the bigger one. So I'm going to cross off this 1/2 and pick 2. Okay, you can literally just circle 2. You don't have to cross off anything. You can just circle it. All right, so let me repeat myself. Okay, I'm going to create a multiple choice problem actually for the stretch and compress portion too, by a factor of, let's see if I can make this bigger right here. Perfect. 1/2 or, okay, now vertically stretch or compress by a factor of 1/2 or 2. So let's look at this. Let's repeat my reasoning. Let's use 1, the whole number, as our reference point. Is 1/2 bigger than, is it greater than, or less than 1? It's less than 1. So because it's less, you would think, because we use the word less, you would think it's a compression, but because we have our opposite hats on, it's going to be a stretch. Okay. Now stretch, okay, again, we create another mini multiple choice problem for the numbers. Stretch means you pick the bigger one, which is 2. There you go. Okay, so vertically stretched by a factor of 2. All right. Now, check this out. I'm going to go, let's go ahead. Let me show you another one right here. All right, and let's go with boom. And now watch this. I'm going to put a 3 right here. Boom, boom. Okay, now this is going to be a, watch this. Now this is on the X side. Okay, so now it's obviously going to be a horizontal. I'm going to set up a mini multiple choice problem for myself. Stretch or compression by a factor of 3 or 1/3. Okay, now let's use the same exact logic here. Okay, we're going to use 1 as our reference point. Okay, now, is 3 greater than or less than 1? Obviously, the answer is 3 is greater than 1. So you would assume that it's a stretch because we use the word greater than. Okay. However, because we have our opposite hats on, it's actually going to be a compression. So I'm going to delete this. Okay. And because it's a compression and it's getting smaller, so to speak, we're going to pick the smaller number, which is 1/3. I'm going to delete that 3. Okay, so this should be our full bullet point right here. Okay, to look like that. And that makes sense because if you look at red, which is our original parent function, and you go to the blue, the red transitioning to the blue means the red got compressed. Okay, it got squeezed, so to speak, to become the blue. Okay. Now let's put it all together. Okay, let's pretend that you have this. Let's go with minus 30. Okay, and let's go with plus 2. I'm going to combine all 4 transformations together, and let's go 1/2. Okay, so you would do this. Okay, let me change this to degrees real quick. Degrees, negative 360, positive 360, negative 5, positive 5. Okay, now, how would this work as a sentence? Okay, boom, and this would be a horizontal translation 30 degrees right. Okay, so I take care of the horizontals first, like I said. Okay, take care of the horizontals first. And then let's take care of the verticals. A vertical translation 2 units down. Okay, and then we have a vertical. Actually, I did that 1/2 on the previous. Okay, I'm just too lazy to go find that slide. Let's just vertical. You would think it's a compression because 1/2 is less than 1, so it's actually a stretch. Because it's a stretch, you're going to pick the bigger number of 1/2 and 2, which is 2. Okay, so this is how your answer will look like, folks. Okay, it will look like these 4 bullets. Again, horizontals come first, verticals come second. Okay, and do the translation first and then the compression stretch later. Okay, just do it in the order that you see right here. Okay. You do. The 3 is what, remember, we created, yeah. That's exactly right. Yep. Okay, so go ahead and do these problems that you see.